Alright, so this is problem 23 from section 10.4, and it's asking to find the area of the region that lies inside r equals 4 sine theta and outside r equals 2. Now, I've written down the formula in orange, and the only thing you have to keep in mind is that f of theta in this formula is the outside radius and g of theta is the inside radius. So if the region is inside r equals 4 sine theta, that just means that's the outside radius, and I've labeled them correspondingly. Okay, and now from there, all we really have to do is figure out what the bounds or the limits of integration are. So a and b, and you can do this by just setting the two functions equal to each other. So 4 sine theta is equal to 2, and then dividing by 4, taking the inverse sign, you'll find theta to be pi over 6 and 5 pi over 6. Or what I did is I basically just graphed them, and I like doing this just to get an idea of what we're actually looking at. Now, when graphing r equals 2, it's really just a circle of radius 2, so that one's not bad at all, and that's in yellow. But the other one, you may think it's a lot of work. I mean, f you do know, so it's a rows function, so if you are familiar with the different forms of this, and what A and B, how it affects the number of petals, the orientation, things like that, then it's much easier just to, if you do remember that, just to go off that. But plotting points is something you can always fall back on. And you don't have to plot that many points. I only really plotted 4 points and then used some symmetries of the sine function to get the rest. So I plotted the standard points, and then from there I know that sine theta is equal to sine pi minus theta. So if I have pi over 6, I know 5 pi over 6 is going to have the same sine value. So basically everything in the second quadrant is just mirrored. And you may be asking, okay, why is there no point like this one? Or in the third or fourth quadrant, why is it all in the first and second when sine can be negative? Well, the reason that is because if we consider polar, you may remember that if we have r theta, it's the same thing as negative r theta plus pi. So over here in the third and fourth quadrant, all sine values are going to be negative, right? So if we have something like right here, like negative pi over 6 is our angle, it's the same as adding pi to this point, and then it's going to be negative. So instead of having it stick out like this, it just flips back into the original orientation, and it's just going to retrace the points we already have in the first and second quadrant. So the fact that we're adding pi and flipping the orientation basically reverts it back to the original. And that's why there's nothing in the third or fourth quadrant. Now, on to the actual problem. So there's a couple ways of finding intersection. I like graphing. And in even graphing, there's a couple ways. Do you want to remember A and B for sine, or do you just want to do points? Now, from there, okay, the actual area. So it's 1/2, and it's the outside function squared. So our function was 4 sine theta, so if you square it, you get this. And then our inside function was 2, so 2 squared is 4, and this is d theta. And from the graph, or the setting them equal, you get 5 pi over 6, and pi over 6 is the limits of integration. Now from there, I'm going to factor in the 2, or the 1/2, sorry, and then break it up into 2 integrals. So I'd get 8 sine squared theta d theta minus 2 d theta. And this is pi over 6, 5 pi over 6. And this is the same. Okay. Now for this first integral, that's something we have to use an identity for, because there's no sign, so we can't really do a u substitution. But the second one is really straightforward, so I'm going to go ahead and continue on. So this is pi over 6 to 5 pi over 6, and the identity is 1/2 1 minus cosine of 2 theta. And that corresponds to sine squared theta. And now that is d theta. And then our second one, we had -2, and the integral of d theta is theta, so it's just plugging in our things and subtracting this second from the first. Okay. From there, this first one, again, it breaks up into 2 integrals, so I'm going to go ahead and factor that 1/2 in, as well as the 8. So that's going to leave us, well, our first term is 1/2 times 8 is 4, integral pi over 6, 5 pi over 6 d theta, because we just had a 1, minus, and this is also going to be a 4 integral pi over 6, 5 pi over 6 cosine 2 theta. And then this is so let's just simplify this. That's the same as 4 pi over 6 or 2 pi over 3. So we have negative 4 pi over 3 when we factor in the 2. From here, so this really just works out to the same thing. So 4, and then it's 5 pi over 6 minus pi over 6. Now this one, the integral of cosine 2 theta is sine 2 theta over 2. And that's from pi over 6 to 5 pi over 6. Minus, and we're just going to pull that down with us. So this first term, the 5 pi, this one, we're getting 8 pi over 6, I do believe. Oops, no, sorry, we're getting 16 pi over 6. And now I'm going to move this one into the front. Okay, and now I'm actually going to do the sign, evaluating the sign, so negative 4 times, and I'll factor out the 1/2 there. Sine of 2 times 5 pi over 6 minus sine of 2 times pi over 6. Okay, so these first terms, if you combine them, you get 4 pi over 3 times just a common denominator. No, 8 pi, sorry. Arithmetic's off today. We've got a negative 2 here, and then sine, this is sine of 10 pi over 6. So I just like drawing my little unit circle. So sine of 10 pi over 6 is the same as sine of 5 pi over 3, which is right here. And that is the same as pi over 3, but negative. So it is going to be negative root 3 over 2. And this next one is just going to be sine of pi over 3, basically, so root 3 over 2. Alright, from there, let's just, I'm going to, let's see, 8 pi over 3, negative 2, and then combining these, we just get negative root 3. So we're left with 8 pi over 3 plus 2 root 3 as our answer for this problem. So there you go, and that is number 23 from 10.4.